Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, in our today's video, we are going to discuss about the stoichiometric calculation. So, let's have a look on this at how we can be able to calculate the masses of the different substances from the given data. So, the first one thing that we have to do it is from the mass of the substance A that is given. So we will use its ratio of the coefficients both A and B, and we will calculate the mass of the substance B from it. So it is its product. So here, for example, we have a chemical reaction in which A is going to convert into the B. Here A is the reactant and B it is the product. And for example, here we have 2A and is going to convert it into the 3B. So from the coefficient of the reactants, we will be able to count or we will be able to measure the amount of the substance B that has been produced. So here if we have given the grams of the substance A, then by using the molar mass of the substance A, we will calculate the mole. So here the grams are given for that for the A substance plus its molar mass. Then we can calculate first of all its moles, and now from the moles we will use the coefficient of A and B. Coefficients are this 2 and 3. We will use 2 and 3 coefficients of the reactants and products that is given in the balanced chemical equation, and we will find the moles of B. So these are the moles of reactants. So here we will find the moles of products by finding the moles of the products. Then we will use the molar mass of product B. So we will use the molar mass of products and then we can calculate its grams. So this is the whole scheme by which we can be able to calculate the mass of the unknown substance from the given data or by the stoichiometric calculations. So let's have a look on the first one example that we have, and it we have to calculate the number of grams of potassium sulfate. So here we have the products that is potassium sulfate and water that is produced when 14 gram of potassium hydroxide is reacted with excess of H2SO4. So first of all we have to write its chemical equation. So what will be its chemical equation? So in the start, we have potassium hydroxide, it is KOH. It's going to react with the H2SO4, and the products we gain it is potassium sulfate plus we gain water. So this is the chemical equation. Now we have a look on whether the reactants and products number of atoms of all the elements are equal or not. So we have to make it a balanced chemical equation. To make it balanced chemical equation, on the reactant side we have one potassium and on the product side we have two potassium. So we will put over there 2. Now the potassium atoms are balanced. On the reactant side we have oxygen 4 plus 2 6, and on the that side we have oxygen 4 and 1. So here we have just 5 oxygen atoms. So we will put 2 over there. Now here we have 4 and 2 equal to 6. So oxygen atoms are also equal on both the side, reactant side and the product side. Next we have a look on hydrogen. So here we have 2 and 2 hydrogen, 4 hydrogen, and here we have 2 are 4 hydrogen complete. Sulfur, there is one sulfur and on the other side there is also one sulfur. So we have a balanced chemical equation over there. So we have a balanced chemical equation. So if we have a balanced chemical equation, now we will start the calculations. So first of all, we will use the grams of the reactants. Here we have mass of potassium hydroxide. It is equal to 14 grams. Next, we will find the molar mass of potassium hydroxide. Potassium, it is equal to 39, oxygen 16, and hydrogen 1. So the molar mass of potassium hydroxide will be 56 gram per mole. So this is its molar mass. Now by using the molar mass, we will calculate the second thing, which is moles. Moles of potassium hydroxide. So moles will be equal to mass in grams divided by molar mass. So here the mass in gram is 14 grams divided by molar mass, which we have 56. So moles of potassium hydroxide we have, it is equal to 14 divided by 56, we will get 0.25 moles. So here we get moles. Now we have the moles of the reactant. So we will compare it with the products. In the first, we have 2 moles of potassium hydroxide and it is going to produce 1 mole of potassium sulfate. So now by the compare method, we will find the total moles of the potassium sulfate that has been produced here. So in the next calculation, we have to find the moles. Here we have potassium hydroxide on the reactant side and we have potassium sulfate on the product side. So to understand this, we have to rewrite the equation over there. So potassium hydroxide reacts with the H2SO4 and it changes into the two products. The first one product we have potassium sulfate and the second product we have a water molecule. So by balancing it, we just find it. Now, if we have 2 moles of potassium hydroxide, then it produces just 1 mole of potassium sulfate. On the other hand, if we have 1 mole of potassium hydroxide, then it will produce the moles of potassium sulfate will be 1 by 2. And if we have 0.25 moles of potassium hydroxide, then it will produce the moles of potassium sulfate. It is 0.125. So this is known as the comparison method by which we can find the moles of one substance from the other by comparing them. So we will have 0.125 moles of potassium hydroxide. So these are the moles of potassium sulfate, which is equal to 0.125 that has been produced from 0.25 moles of potassium hydroxide. Now we have moles. So by finding the molar mass of potassium sulfate, where potassium we have 39 mass number, sulfur we have 32, and oxygen we have 16 multiplied by 4. So at the end, its molar mass will be 174 gram per mole. So this is the molar mass of potassium sulfate. Now we will find the total amount of potassium sulfate produced. So we will apply the formula where mass of potassium sulfate, it is equal to moles of potassium sulfate multiplied by the molar mass of potassium sulfate. Here we have moles 0.125 multiplied by its molar mass, that is 1 74. So by solving that, at the end, the answer we will gain it is 21.75 grams. So this is the total mass of potassium sulfate that produced from the 14 gram of potassium hydroxide. Now we have to find the number of water molecules that has been produced, or we will compare the moles of potassium hydroxide to the moles of water molecule. In this equation, here we have 2 moles of potassium hydroxide produces 2 moles of water molecule. So if we have 1 mole of potassium hydroxide, it will produce 1 mole of water. And if we have 0.25 moles of potassium hydroxide, so it is going to produce 0.25 moles of water molecule. So the number of moles that has been produced in this chemical reaction, it is equal to 0.25 moles, and these are the moles of water. So now we will find the mass of water produced, which is equal to moles multiplied by molar mass of the water molecule. So the moles we have 0.25 multiplied by molar mass of water molecule is 18 gram per mole. So the answer we will have it is 4.5 grams of water molecule will be produced in this reaction. So next, the last step is to find the number of water molecules. So the formula to find the number of water molecules we have is equal to moles multiplied by Avogadro's number. So when we multiply the moles with the Avogadro's number, here we have 0.25 moles of water molecule, and we will multiply it with Avogadro's number, where Avogadro's is 6.02 into 10 raised power 23. So the answer we gain it is molecules of water. It is equal to moles 0.25 and 6.02 into 10 raised power 23 Avogadro's numbers. We will have the total number of water molecules will be 1.5 into 10 raised power 23 molecules of water will be produced in this chemical reaction. I hope you guys understand about the calculations that are basically stoichiometric calculation. And if you guys have any queries, you may ask me about that. And in the next, we will discuss about the limiting reactant. So you guys keep learning and have a good day.